Hello guys, in today's live stream we will continue our Starbucks review dataset. I'm really sorry for yesterday's stream. Yesterday there is some problem in my internet connection. That's why the stream got you can say stopped. So what we have done yesterday. We have tried bag of words and TF IDF and word to vec for converting our you can say text into vectors. So today we will try to you can say we will try a pre-trained model for a pre-trained model of word to vec which is which is of you can say Google. It has 3 million words, and then we will try to predict for from the that model. Let, let me try to run this. Um, Let me do one thing. Let me write here. Pre-trained model. It will take some time to run. Till then, what we can do, we can define our vectorizer. Sentence dot split. This will split my words from sentence. Then words to vectors is equal to, we will create a for loop here for our model name is W V of you can say that word for word in words. It will take some time because it is a very large model. Let me, you can see this is pattern vector model for 3 million. This is trained on 3 million words and phrases. So our data set is loaded, or you can say our model is loaded. So W for prediction we will use like dog. You can see we get a shape of around 300. Let me do dot shape. You can see we are getting 300. Let me check how to. What if we give dog? What if we give a random word? Doggy not present. How we can uh, tackle this warning? Let's see. Because there can be many words which are present in our review but not present in this corpus. So how will we handle it? Let me do one thing. Let me try ChatGPT. Also today there is some problem with ChatGPT, I guess. Yes, that's what it is. Loading very slow. Okay, we can try part also. Let's see how it will perform. Let's see what it will. Okay. Well, this is taking some time. Okay, so the okay, the key has been raised because the login not present in vocabulary. This could be because the word dog is not a real word or because it is included in, not included in corpus. I guess. To fix this error, you can try one of the following. Check the spelling of T. You use a different key that is known to present in. Okay. Train the model on a larger corpus that includes the word. Okay. If you are not able to resolve the error, you may want to contact the developer. Use in keyword to check if a key is present in model's vocabulary before trying to access it. Use the get method instead of to access model vectors. Will return a default value if the key is not present, while the operator uh, will raise a key error. Okay. Make sure that the corpus you are using is large enough and diverse enough to capture the vocabulary of your target range. So what we can do, one thing we can do, we can use get method. Another is we can use in keyword to check if a key is present in model's vocabulary or not. Let me do how to check word present in model's vocabulary. Or you can say code to check, write Python code to check word present in model's vocabulary or not. let's say what it will give. Okay, so we can this is not giving me desired output because this will just to accept return false. Okay, for a moment let's try this code. Instead of you can say model, we have wv. It's present in okay. But it will return false. Okay. So what we will do? Let's try our get method also. We can do wv dot get and give here dog. There is no attribute name get. Let's see. Get index, get main vector. Here we will give dog. So these are two different vectors. We are not getting the same. What you can do dot. I guess there is a command to find all you can say all possible methods. And that here what we will do now is let me again Google this Jensen workbook. We can do one more thing. We can create a function uh, for this. Let me delete this and also delete this. here what we will do, in vectorize we will use okay. Okay, so it is live. Uh, for words and for word in words, what we can do, we will do the if word in how to check corpus code. Is there any corpus command or capitalize enter contain was replace and title split and strip. Now we are how to find corpus set similar by okay, no find for we can do let me do correct indentation try instead of model we will use wv, then it will return us true except it will return us false. Okay, if it is true, then what we can do, let's go back to this. Let me paste it here. So this is of 300. Before that, we will initialize a word vectors variable as empty list, and then it will return us. Uh, it will just append append inside words column in when it will return key error, we will do just np dot array zeros of 300 size, and let's see it will run up. It will return us what if dot name of size axis is equal to 0. Append and void. Let me check am I correct or not. So I will create a new list. It is equal to empty list. Now what I will do, I want to add dot append inside EDA. Yeah. Okay, so what we have to do, EDA dot append dot is. Okay. So here instead of word back we have to do this. And here we have to write words back. First we have to check, let me define here empty list. Now can we convert this into np.array or not? Array of, okay, we getting empty array, which is nice. After that we have to run for, or we can create a new function. uh, let's do now create a new function for, let's first try this function. Let me do check. Let's see. Right, correct this code indentation. Let's see. ChatGPT is running. I see something. So now I guess this is correctly intended. Okay. Yes, it is correctly. And try this code. Okay. So we get our x. Let's see. Shape of x. Okay. Nice. We are getting 189, 300, which is right. Now let's try to train this. Okay, you can see here our accuracy score is very increased by 57, which is a great news for us. Now we can use multiple models for training, and we will find out which will be best suited model for our problem. Uh, Now let me just So there are all different algorithms which we can train upon. Let me copy this part also, and then I will explain what's going on. Let me also import all other libraries. We can also copy. So we need shuffle, split, grid search CV, close. We do not need this student split because it is already there. We need logistic regression, SVC, TC. Okay, all these algorithms. We have this. We are not doing PCA. Okay, let me run this plot. Now let's run this, and here you can see we are splitting our data into 5 splits, and our test size will be 20%. Okay. Let's try training our model, and then converting this into a data frame where we will get a model name with their best score and for best parameter. Here you can see we have multiple models with their different parameters. So it will train for all these possible, you can say all these possible values. Like first it will train for this model, then it will train for this model, then it will train for this model with this and this parameter, then it will train say, this model and for this parameter with this for this hyperparameter and this hyperparameter, and then for train with this hyperparameter and this hyperparameter, and then it will find the best possible parameters, and we get here. I think this we can take some time. Also in my mind there we are, so here you can see there is very high F1 score for what I'm thinking, we have this multi-class classification problem, and our data size is very small, so we can do one thing. We can convert this into binary classification problem, and what we will do, we will do instead of rating, we will convert this into, it is you can sentiment analysis type, like we will give this as rating 1, and we will map 1 and 2 with bad rating, and 3 4 5 with you can say good rating. uh, let let me open calculator. Then we will see if our data set will balance or not. We will take some for 1 and 2 as you can say good, bad. Then for bad we have 550 reviews, or and for our good rating it will be 155. Then this will also you can see this is also imbalanced data set. What we can do now, let's convert, take 1 as bad and 2 3 4 5 as good. Let's see, so this is for you can say bad rating, and 99, 83, 39, plus 33. So we will get 254. We can do one more thing. We can downsample this. Then let's see. Now till now, just wait for finding best fitted model. Let's see how much time it will take. Till then, what we can do, we can try this for let's start converting our data into uh, from we are converting our data frame, our problem into from multi-class from multi-class classification problem to you can say binary classification classification problem. Here what we will do, let get this explained. Now we will we will map one as bad and map rating and rating 1 and 2. Let's do and map rating 1 and 2 as bad and rating 3, 4 and 5 as good. So now we will map. Let's check what's our final data frame. So we have balanced here, but we will work on this TF column, this TF data frame. Okay. What we will do now, we will create a new column name as we can say binary rating. So negative addition first. Okay. I guess it should not be. Let's remove this. Now you can see this algorithm from, or we can do one more thing. Let me add that part also. Multinomial. We can perform scaling in this. Let me just. We'll paste it here, and what we can do, we can do scaling from scikit-learn dot I guess main scaling is presenting pre-processing. I guess pre-processing import min-max scalar is equal to min-max scalar, and then we will give x as a scalar dot fit transform into x. Let's try to run this. So we executed our form. Now let me try this. Again, it will take around 8 to 10 minutes. Let's see how much time it will take. Till then we will continue with this part. So what we will do, we will map df of what's column name, it is rating. Let me cross check. So it is rating column. Okay. Dot map. Now we have to give the dictionary. One with map with bad, two with also bad, and then three with good, four with good, and five also good. Okay, then what we will do, we will create again a new data frame in which we will separate our this data frame into two parts. RTB, in which we will take df which has df of b rating as value bad, then RTG is equal to df of df in which b underscore rating is equal to good. So now we splitted our data frame here. Now what we will do, we will do rt underscore g dot value counts. No, we have to do, okay, at this moment we have to do b underscore rating dot value count, and then so we know that we have to downsample our data. Balancing our imbalanced data set. So then what we create, again we will create a new data frame balance df1, in which what we will do, we will concatenate pd dot concat we give x is as 0. First we have to take rt of b dot sample. Also we have to give random state as 10, or you can give any value for this purpose, and then rtg. Currently I am not giving any values here because I don't know what's the value count of the, you can say, of the reviews. That's why I'm not doing this. Let's see, it out on 5 minutes. So now our data set is balanced. Now what we can do, we can start, also we have to do one hot encoding. Now what we can, on balance df1 performing one hot encoding on b underscore rating column. Let me get this in. We will save this in balance df b underscore rating. What we will do, we will do balance df b underscore rating dot map. But it has to map, it has to, we have to give a dictionary, map bad as 0 and good as 1. So this will map. Then again we will say b underscore rating dot value counts. So we have performed one hot encoding. Now it's now it's now we have to do you can say we have to convert our reviews into uh, review reviews into vector, or you can say we have to convert our text part into uh, text into vectors. Let me check in our DF data frame our reviews are cleaned or not. So in our balance DF we have our clean reviews. Let's check for DF. Okay. So in DF column we already lowered our reviews, splitted all the reviews and removed stop words and perform lemmatization. Okay. So our you can say DF is clean. So first again we will try all these methods. We will start with bag of words and then TF-IDF, then word to bag. See, you can say continuous bag of words and then use skip gram also. It's now now just we have to do copy and paste. Let me check all our yes, it is correct. Converting words into vector. First we will use bag of words. I guess we do not need to again. I guess there is no need to again define it, but let's define it again. So this method we again define it again. First we will do it for 1 comma 1. Instead of balanced TF we have balanced TF 1 now. Again then we will try it for TF IDF. Let me check and then we'll yes, I am online. So we have to put TF IDF. Also again, I guess we have to define our corpus for continuous bug overrides and skip rounds, and then continuous bug overrides. We have to do. So here we get our result. Again, we are getting around 57% accuracy with this logistic regression model and 38 with random forest with Guinea as criteria for okay and an estimate for 50. Now let's train it for random forest. Training with random forest classifier. Let me paste my code here. Forest random forest classifier. Forest dot fit. Let's see how much accuracy score we get this time. Here you can see we are getting around 57% accuracy score, and in logistic regression we are getting around same score. Then why? Let's try with this hyperparameter. For criteria Guinea and an estimate. Guinea and the number of estimators 50. We are getting around a similar score. So let's I remove this part. One. Okay, so we have trained it for you can say logistic regression. Now we will convert our multi-class model into binary class. Now let's okay. Still, this is heavily imbalanced. And here we will do 155. Here we can drop our D. Drop, you can say drop, but we want to drop a rating column. Axis will be 1 and in place will be 2. Okay, nice. So we will try with our now. Let's see how's our balance TF head now. You can see. Now we will first do with count vectorizer. After training x, let's go back to it is independent dependent variable. X dot shape. So this is now around 310 columns. Oh no, sorry, 310 unique reviews with the shape of 2772 vectors. Now what we will do? Dependent variable. In balance TF1, we have B rating as our Y. Let's check. We will count. I guess it will be 155, 155 here is okay. Now we have to use center split. Splitting between training and testing set. Now, now check y test dot value count. Here you can see they are both are in same ratio because we don't stratify is equal to y. That's why these all are in same ratio. Now comes the part. Now comes the training part. After training, let's it should be in as a heading. Then what we have to do, predicting, or you can say accuracy score. Let's see how much accuracy score you will get. Score X test, comma Y test. Now our accuracy score is improved. See, also we can now create a confusion matrix. Cn is equal to confusion matrix. First we have to do y true, that is y test, and y pred. Also we need to define y pred. Y pred is equal to clf dot predict, and we have to predict it with predict for x test. Then we have to create a heat map using cn. Annotation will be true, and we have to dot show. Also we have to give title. We have to dot title, and it will be heat confusion matrix. Confusion matrix. You can see we get a nice visualization. Now what we can do, we can create a classification report. Classification report y test, y pred. Here you can see we are getting around 68% of one score. We can do one right more time also. Here we can do accuracy score, then it is confusion matrix. This is our classification report, and it should be happy. Now what we can do, this is using count vectorizer. Now we will try to hypertune this count vectorizer. Now we are getting around 67% accuracy. Let's do it for 1,2 and then check how much score you will get. Let me run this complete. This time you can see our accuracy score is dropped. Also it is 68 and 67. Now let it do it for this time 1,3. Okay, let's see. Still this is less than as compared to our first case, where our parameter is 1,1. So this time let try it for TF-IDF. Let's run this. Okay. Here you can see our accuracy score is around 77%, which is very nice thing. Here you can see F1 score is 81, and for 1 it is around 73. Here you can see our report score is very good for 0, and precision score is around 90% for 1. Now we can hypertune this TF-IDF also. I guess that is also, yes, also hyperparameter in n-gram comma range. Let's do it for 1,1. So our accuracy score is around 77. Let's see. Okay, by mistake I created a huge blunder. I have to interrupt my kernel, and from starting I have to run. And I guess after that we need to run this command. Let's see. So this one is 170. This is 171. I guess we need to import our test split part and then this declaration. Let me paste it here and run this. So now let's go back to here. From here we have to run this again. Now we will train it for TF idea. Let's see. So this is giving me again 77% accuracy. Now again let me do it for 1,2. Let's see. But we will be changing accuracy score. Again I'm getting around 77% accuracy. But this time my variables are you can say vector size is around 13,000, which is very high as compared to my you can say row size. Now this is open. So for this part also we have 1,1 as best you can say hyperparameter. Now we will train for you can say continuous web of word. Let's see. For continuous web of word, first we have to create a corpus in which we have our all vocabulary you can say. Let me paste it here. For this time we have to run for df1. And I guess I have to balance df1 dot ilog 0, 0. Then I will get the rating. Yes. For 1, I will get the rating. Good. So instead of 1, we have to write 0. And this is correct. Okay. So we created our corpus. Now it's time to first we have to initialize continuous web of words. Here we will give our vector size as 100. Here we defined our vectorizer, and here also our size will be 100. Now it's come for define x. Let me paste it here. X is equal to np dot array. Okay, for a balanced df1. Now let me check how's our x shape is 310 comma. Now so it has a negative value also. Now what we can do, we can scale this uh, uh, part for, but we should scale it here. Feature scaling. Here we can define from scikit-learn dot you can say pre-processing. We imported a min-max scaler and define scaler is equal to min-max scaler scaler dot fit transform x train, and we say this in x train itself. Then we will transform our x steps using scalar dot transform x underscore test. Now from here 218, let's run, and we get around 45% accuracy, which is quite low as compared to TF-ITF. So now we will try it for you can say skip gram. I guess using a skip gram we will get similar accuracy as well as in case of C Huygens continuous backwards. Now let me first define this. Now let me copy for skip gram. We forgot to hypertune this uh, continuous backwards. So this is for you can say vector size is 100. We are getting around 45% accuracy, but let's try it for 500 vector size. Oh, we need to do 500 here. Let me give them this. Here you can see, and after that again you can see still our accuracy is around 55%. Here you can see it is predicting very bad for one, because here recall is around you can say 6%. Now let's do for 200. Let's see this time what will be the accuracy score. It is again around 45%. Still the same results. Now move forward with scripting. Here our vector size will be around. We need start. Just a second. Here it is 200. Then we forgot to upgrade. Let's we have to run this. It is again around 55%. No change in score. So this time we will depend skip down as 100. Now we have to do it for skip rank. Skip rank. And here our vector size will be 100. Okay. Now again we will run this entire code. You can see here we are getting around 45% accuracy again. As I told you, if see a continuous web over skip RAM give around same accuracy. Good. 500. Still giving us the same accuracy. Now what we can do, we will again do train it for word to vec Google pre-trained model. Google News pre-trained model. I guess like previous time, we will get maximum score accuracy score using this model. Let's see. So because our kernel was interrupted, that's why we have to again do this, or you can say download this part, download this API. And I also read it somewhere that multiple nomial uh, uh, algorithm is naive Bayes algorithm is best for text. You can say for NLP part. So that's why instead of logistic regression, we will train using multinomial uh, naive Bayes model. But for this time, we will use logistic regression for balanced TF1. Let's see how much time it will take. Uh, uh, till now, we are getting maximum accuracy using TF-IDF around 77%. Let's see how much accuracy this model. Oh, we are getting around 83% accuracy, which is very good. Here you can see our recall for 0 and precision for 1 is very high. You can see we are getting good results. Also, we can, I guess, improve these results by using multinomial model. Let's define here from scikit-learn dot naive import multinomial NB, and instead of just regression we will use multinomial NB, and I guess from here we are getting around 83%. Let's see how much we get from multinomial NB. We are getting around again 83%. We are getting similar results. No such change in results. Let's try it with random forest from scikit-learn dot ensemble import random forest classifier, and here it will be random forest classifier. Let's run this and check. Here you can see we are getting similar results, and this time we are getting, you can see our score is distributed uh, in this both. Here you can see we are getting just 4, 4 and 6, around 10 incorrect predictions. Now we can do one more thing here for you can say increasing our data size, data set size. What we can do, we can here map to with also good. Let's write this. Then the value count will increase for good. Okay. Then we have to do the same thing. This time 254. Here you can see. Now what we will do, we will just train for this pre-trained model. Let me check now X shape. Now here you can see it is around 508. then we do not need to do this part if we train for random forest classifier. Let's see what will be the accuracy score. Our accuracy score is dropped. Here you can see. And now we can do one more thing. Let's try it for logistic regression or multinomial. For multinomial NB, we have to scale our data from 0 to 1. Let's see. Here you can see here we have to scale our data and then this. You can still it is giving us 75%. Now what we have to do, we have to try it for logistic regression. Again 72. So we are getting bad results by doing this. Again we will map back as bit bad. $155, like yes, it is. Here for we are getting best result using this group news pre-trained model. Again we have to train up here. Then this we will do this. Nice. So what we can do now, we have trained our model for binary classification and for multiple. Let's check what's the score for multi-class classification. Let me remove this part. We will develop this. So here the accuracy score is around 57%. Now we can do one thing, that we can use both models. And then it will convert into sentient analysis. Let's try. Now what we will do, we will save our this multi-class classification model for our creating our website part, or you can say Flask web. Then we have to run this command from this. Yes. And we have to run this command. I guess it will be. You can see this prediction. We are getting still I don't know why we are not we are get why we are getting 0%. Okay, I guess now I get in my y test there y test dot value counts, it will be 0 for 3. Now it has 6, then why it is predicting 0, or you can say giving a 0 score. What we can do now, saving our model. uh, Now we will import pickle, and then we will save our model. Let me check. And our model name is you can check. Our model name is CLF. CL. PQ. Okay. And then also we need to save our so we do not need to save this because this is an API. We can load it using Jensen. Okay. So what we can do now, we can move to creating our weather part. Let me do one thing. Let me just go to the sample weather templates app. What we do, just we need these two things. Let's go to this and paste it here. Now you can see we get a weather. Now at this time first we have to do, we need to import numpy. We need to import this part also, analytical also, and then first it will load model.pkl, and it will route to index.html. Let me go to index.html and remove this style part. And this time we in our body we have just one variable. Just remove this. Let me just remove this. Also remove this. We will rename this. Instead of blood glucose level, write your review here, and we will give this a review and name it review, and inside title we will give this as star bugs review, rating, prediction. Now we can copy this part and paste to header 1. So this will be our home page. Now we can delete this force.html, and we just need, or we just undo. Yes, we can delete this, and we just need prediction.html. Let me here you can see. Let me just copy prediction.html and copy to Starbucks review rating prediction, and also let me copy this web app instead of, so this is our index.html, and inside prediction what we will do, let me again copy this item and paste it here, also paste it here. You can say here we can type from your review, we can say we can predict you will give us rating as you will score us. Out of 5. You will, or you can say you will rate us. So this is our prediction part. Now we have to go to our app.py. Here we do not need scalar. Okay. In index.html. Okay. Also in index, here is just one review. Let me remove this entire part. And it will be review. Now after this we have to do pre-processing. Now we have to do here text pre-processing. Text pre-processing. Now let me go to my notepad. We will do for text pre-processing. First we have to review. Also we have to set this as review. Also we have to check, can we use if we very good, and then if we do 7, and if we will run, and if we run this, what we will get? Let's see. String do not has a dot replace. Then we have to, I guess, import RE, that is regular expression, and then we have to do this. Okay. Let's go. I guess I have a rating. We have to import RE. Also for a practice I have to write and then inside pattern we will do for regex. We have a nice website. Here we can find our regular expression. Now let me check it for this one. Let's see this one. It should work. Okay, actually, that was correct because we are replacing that case. But in this case, we are just now we get all the empty strings. Now we try to join this one. Okay, let's search for A to G and A to G, capital G, and then star. Okay, now we have to do this in the IS string format. Let's check. And let me check this type. So this is in the list. Words, and then I have to create a new list or for sentence is equal to a sentence will be for loop where the word pro or we can do sentence dot append inside a word for word in words. Okay, first we have to define sentence for word in words. We have to open sentence. No, this will not work. We have to give sentences and then what we have to do word in for I in range length of words. Then we have to take our words of I the append sentence dot append. Let's see. Okay. Oh, I'm sorry. We have to give this instead of append. We have to type join. That's Now let me check my sentence. And write a Python code to join all string element or string values of list in a single string. So if we have this, we have to use dot join. Okay, empty string dot join words of 0. We get very high. 0 to 10. Okay, we have how many words? Let's check. We have 3. Okay, we have 10 words. Okay, so this is the program. Resistance item string. Okay, let's give here my complete. Now let's check something. So here we get our, but here we get all our characters in a single string. Write a Python code to convert my string into just word, just convert my review into just all character values. Let's see. So here what we have to do when we get our review, for vector and review. Now my review is very good coffee. Let me give some numeric values and then some symbols. Let's see what we will get in claimed review. So these all are in same. I want all words separated by space. Oh, so now I get it. For that we have to just add space here, I guess. Now then it. Okay. Now I get it. Yes. Here we can do this. Then sentence. Okay, you can see. Yes, we can use this, and now what we will do again. And instead of this, we have to give our review. Okay, and we imported our RE, which is nice. Now I think we have to split our data. Let's see. Okay, so we get this. We have to import limitizer also. And we have to do this one. Login the review by review. We get the words. Pin again. Then remove subfiles. Also, we have to import uh, we need to import nmtk tk and dot stop. Let me check. I think this would be corpus. Corpus. We need to import that is stop words. Okay. Now come the monetization part. Then again join the words. Now let's see what's next. Now we get our clean review. Now we have to convert our load this part. Now we have to again define this function. We can write here vector first. We can trace our review. So we already copy. Then after that we do not need to do anything. And then this we have to predict. We have to predict it for vectorized. And that's debug equal to true. Let's save this and try to run this. Why does it take so much time? Okay, this is taking so much time because it has to download this complete model. Okay. Then if we get any problem, we will work on that tomorrow. I think this will be enough for today. Let me check. This one. But we have to do this sometime. Let's check. But this is getting taking some time. We will work on this tomorrow, I guess. This is enough for today. Tomorrow we will see why our web app is not running. So let me close my data. Control C.